What comes to mind when you hear the word space? What is it about? And what is the concept behind it? Those have been the major questions scientists have spent decades, if not centuries, to explain. I think that everything about space that we as humans have ever seen and experienced has been portrayed to us in black and white. Have you ever considered seeing the universe in color? How do you believe this might be accomplished? You may be familiar with the James Webb Space Telescope. Are you aware of recent discoveries of crystal clear images in space? Let me walk you through the findings made by the James Webb Telescope that we have never seen before. Before we begin, don't forget to like and subscribe to this channel for more intriguing videos like this. And be sure to watch this video to the end. Without further ado, let's dive into it. The first photographs from the James Webb Space Telescope of high scientific caliber have been made public. The oldest galaxies ever observed by human eyes, proof of water on a planet 1,000 light-years away, and amazing details illuminating the birth and death of stars may all be found in them. Webb's mission is to investigate the beginnings of the cosmos, galaxies, stars, and life. And the 5 photos that were unveiled on July 12, 2022, deliver on that promise. Astronomers jumped at the chance to use Webb as soon as the array of instruments on board had all cooled down and were operating without a hitch. The data in the initial photos are sufficient to generate significant scientific findings on their own. The full red to mid-infrared spectrum, which includes light wavelengths that are filtered out by the atmosphere, is what Webb was built to collect. Additionally, Webb can capture images with a level of sharpness unmatched by any other telescope, thanks to its enormous mirror and sunshade, which block the infrared light emitted by the Sun, Earth, and Moon. Since team members from the Webb telescope published enticing test photographs, there has been a flurry of excitement among professional astronomers, and the actual pictures are even more stunning than anyone could have imagined. Webb project scientist Jane Rigby said, "For Webb, there is no blank sky. Everywhere it looks, it sees faraway galaxies." During the presentation where the first photographs were shown, the majority of those galaxies were previously invisible. Astronomers refer to this galaxy cluster as SMACS 0723 in the first Webb image that the public has ever seen. It is 5.2 billion light-years away from Earth and is located in the southern hemisphere sky. The images of tens of thousands of individual galaxies are incredibly detailed. You should view the image in its whole and zoom in to appreciate the nuances, since it is like the universe in high definition. The cluster's big white galaxies in the image's center are around the same age as the Sun and Earth and are part of it. More distant galaxies surround and are scattered among the cluster galaxies, but they are magnified and stretched into stunning arcs. And indeed, that is what is taking place. Due to the attraction of the much closer cluster, the background galaxies, which are considerably farther away from Earth, look magnified despite being much farther away. The SMACS 0723 galaxy cluster, which first appeared more than 4.6 billion years ago, or around when our Sun also originated, is where the white circles and ellipses come from. You can make out faint red galaxies in the background that are dispersed across the sky like rubies. They are even more distant galaxies. Astronomers can establish the formation date of these early galaxies more than 13 billion years ago, as well as the relative quantity of various elements within them by taking precise measurements of their brightness. The light from older galaxies, which has traveled more than 13 billion years and bent around the foreground cluster, which serves as a gravitational lens, is what causes the reddish arcs. When compared to its predecessor, the Hubble Space Telescope, which was deployed in 1990, Webb is not only producing exceptionally fine images, but it is also doing so without any difficulty. The Hubble Extremely Deep Field required 2 weeks of exposure, whereas Webb went deeper before breakfast, as Rigby remarked. Astronomers will be able to observe some of the first stars and galaxies that formed immediately after the Big Bang, after Webb carries out longer observations that enable it to collect more light from dim stars or galaxies. The second revelation was a spectrum, which is a breakdown of the brightness of light at various wavelengths, rather than an image. As the exoplanet WASP 96b crossed in front of its present star, Webb pointed its mirror at the planet, which is a massive hot gas planet orbiting a star roughly 1,000 light-years from Earth. A fraction of this star's light that was filtered by the planet's atmosphere during this transit left a chemical fingerprint in the light's distinctive spectrum. The characteristics of this fingerprint imply that WASP 96b's environment contains clouds, haze, and water vapor. One of more than 5,000 known exoplanets in the Milky Way is WASP 96b. The idea of targeting Webb at smaller stony planets like our own Earth to look for atmospheres and pools of liquid water that might support life is what intrigues astronomers. Astronomers anticipate finding the signatures of oxygen, nitrogen, ammonia, and carbon in the form of methane and other hydrocarbons as Webb moves on to examine smaller worlds that might potentially support life. Finding biosignatures of life, or chemistries that would suggest that living things have altered the atmosphere, is the objective. This initial result only scratches the surface of scientific content of the spectrum due to the immense technical difficulty of doing this type of observation, known as transit spectroscopy. The telescope did this by using a technique that no other instrument can do at the same level of detail, comparing starlight that has been filtered by the planet's atmosphere as it passes across the star to unfiltered starlight that is detected when the planet is alongside the star. As the telescope investigated the birth and death of stars, the last 3 photos demonstrated the extraordinary resolution of Webb's optics. The cosmic glyphs photograph from the star nursery known as Carina Nebula may be the most stunning. The mid-infrared light that Webb can detect enables its cameras to pass through dense gas and dust clouds. This skill enabled Webb to photograph breathtaking details of the star-forming Carina Nebula. Here, Webb has for the first time shown previously invisible regions of star formation, revealing new information that will help us understand why stars form with specific masses and what factors affect how many stars develop in a given region. Webb is also ideally equipped to investigate how stars die. Older stars can expel their outer layers, creating magnificent nebulas like the Southern Ring Nebula that Webb photographed. The photograph showed previously unseen features of the material waves that the dying core star ejected over time. Webb gave the first view of the binary star system that created the nebula, while Hubble was unable to see through the enlarging cloud of dust and debris. Stephan's Quintet, a collection of 5 galaxies 300 million light-years from Earth, was depicted in the final image from Webb's coming-out party. 4 of the galaxies are close to one another and engaged in a cosmic dance of recurrent close encounters. The Webb telescope can simultaneously observe the details of individual stars in these galaxies, the cold gas and dust that fuels star formation within these galaxies, and most impressively, the material swirling around the supermassive black hole at the center of one of the galaxies by blocking out the stars, gas, and dust. Webb was able to cut through the dust and gas clouds at the galaxy center to gain new knowledge, such as the speed and makeup of gas outflows close to the supermassive black hole. It will take months to evaluate and study the data Webb collected on the spectra of the hundreds of distinct star-forming areas in the quintet. According to cosmologist John Mather, by examining it, you learn how the galaxies crash and merge, adding that our own Milky Way was probably put together from 1,000 smaller galaxies. Knowing more about the black hole will also help us learn more about Sagittarius A, the dust-encrusted black hole at the core of the Milky Way. Webb is the product of 25 years' worth of labor by hundreds of scientists, engineers, and administrators from a global alliance of space agencies, businesses, research institutions, and universities. Project manager for Webb, John Mather, recounted the journey with emotion. This was difficult to undertake. It is challenging to convey how challenging this was. There were countless possibilities for things to go wrong. However, nothing went wrong. Everything came together, and the world's largest space telescope is now operational. As you now know, the concept of space is becoming more clear as time passes, and this telescope has no doubt helped in this research. That's all for today, folks. For more videos like this, don't forget to like, subscribe, and enable the notification bell. See you in the next video. Till then, bye for now.